Now that we've got our diagram and we've got our procedure, we're going to actually perform the experiment. So right now we're starting at about step 5, and what we're going to do is we're going to insert the raw ends of our wires, okay? And we can see this in the diagram. We're going to insert these into our test tube. Okay, and once we perform our investigation, we're going to make sure that these aren't touching each other. For now, we're okay. So let's go ahead and let's go down to step 6. We want to connect our holiday light to our positive feed. So here you go. Go ahead and connect your holiday light to your positive feed. And let's remember that positive is red, okay? So we're going to connect our holiday light to the red right now. Now we're going to connect it to the other side of this red wire, which is going to lead to our battery. Okay, so we're always reflecting on our diagram. Okay, connect that to the positive terminal on the battery. Okay, now we're going to connect our negative wire also to the battery, and we can see this in our diagram. It goes from the test tube directly to the battery. Okay, now we're noticing now that our light bulb is not lighting up in the pure water. Okay, we want to make sure that that isn't our mistake. So we're going to go ahead and touch both of the raw ends, the positive end and the negative end together, just to see if we have any electrical conductivity. Okay, so that's the copper right now conducting the electricity, not the water, but we know that our system is working properly. Okay, our circuit works, it's lighting the light bulb. Okay, now we're going to take it from this test tube, okay, which remember is our control group, and we're going to put it into our other test tube, which is our test group. Okay, this is the one with sodium chloride in it. Okay, and we're being very, very careful not to touch the two feeds. So we are getting electrical conductivity here. The light bulb is lighting up. Okay, it's not very bright. Okay, it's not as bright as if we just had copper to copper, but it is bright. So what we've done is to turn this into a quantitative metric. Okay, so we can actually measure this in numbers. Is we've just made a simple brightness scale. 5 would be right here, the copper wires touching each other. Okay. Now, when we put it into the solution, it's not quite a 5 anymore. We're going to call that a 3. Okay? So when I record these observations, okay, we've gone all the way through the steps here. We just tested the conductivity of the control group and the test group. Now we're going to record our observations and results, and we're going to do this in a lab book. And we would write down in our lab book, test 1, which is the first test that we just performed, okay, that we had a brightness of 3. Okay, so now what we've done here is we've introduced a third test tube. Now this test tube has about half as much sodium chloride in it than our original test group, okay? But it has obviously more sodium chloride in it than our control group because we didn't add any to this test tube. So this is kind of an in-between. And what we're going to do here is we're just going to test the brightness. I wonder if we modify the amount of sodium chloride, if it's going to affect the brightness of our light bulb, okay, and affect the actual electrically conductive properties of the water. So we're still testing our independent and dependent variables here. We're just testing them in a different way, and we're going to see what types of results we get. So let's go ahead and let's put that test tube in. Let's run the test one more time. Okay. Okay, let's watch that light bulb. Okay, so we're getting a little bit of brightness. It lasts for a second and then it goes out. We're going to go back to our metric again. We're going to go back to our scale so we can get a quantitative data point here. Okay, now I'm going to say on test 2, okay, that one, it wasn't completely dim, but it definitely was not as bright as the last one. I'm going to call that one a 2. And I know that this is a little bit objective, but we have to have something to actually quantify this. It makes it a little bit more scientific. So now, test 2, I would call this in my lab book, okay, when I'm recording my observations and results. Remember, we're still at test 10, or step 10 here. I'm going to record that when I had half as much sodium chloride in the water, the brightness of the bulb was a 2. Okay, so that just gives me more data to support what's ultimately going to be my conclusion. I have to have evidence to support my conclusion in the end. When I add sodium chloride to the water, yes, it is increasing the electrical conductivity of the water. Okay? Okay, so now to close, let's just recap, reflect, and review on the scientific process from beginning to end. Okay, the first thing that we want to do in the scientific process is we either want to identify our problem or develop a comprehensive question that will guide us through the scientific process and the scientific investigation that we're performing. The next thing we want to do after we have our good question is we want to pick out and identify those variables. Remember, we have independent variables, Those are our cause or our action. And we also have dependent variables. That's going to be our effect or our reaction, okay? So the independent variable is the cause of the reaction, okay? That's something always important to remember. Then we're going to develop a hypothesis, and we're going to recycle our wording when we develop our hypothesis. We want to keep the subject of the investigation in context, so we're going to rephrase our original question, okay? Then we're going to have a materials list. Remember, our materials list is like our shopping list. It's all of the materials that we need to perform our investigation. We want to take care of that right off the bat, figure out what materials we need. Remember, with our materials list, probably before we start our procedure, and this is going to be in most cases, we're going to have a diagram. Okay? And our diagram is our virtual model. It's complementary to our procedure because we can develop our procedural steps while we're drawing our diagram, and then it complements once again by helping us make it through the procedure and actually construct our practical model that we're going to use to perform our investigation. After we have our procedure, we're going to start testing, okay? And every time we run a test, every little thing that we notice, we're going to document in our observations and results section. Some of the things that we document are going to be quantifiable. There's going to be some type of a numeric metric. Remember, we developed a scale, a brightness scale. That's a quantitative analysis, okay? We're using numbers to quantify our observations, but we also have qualitative analyses, okay? Maybe we notice that there's clouding in our test tube due to the electrical conductivity. We would document that clouding, but we're not putting a numeric value on it, but we are noticing it. That's qualitative. We're using our senses to observe something that's happening during our tests. After we have all of our data collected, we're going to start writing our conclusion. Once again, we're going to recycle the wording from our original question and from our hypothesis so that we can keep the context of the investigation very focused, okay? We're always focused on the subject of our investigation. We never want to stray from that. So in our conclusion, we're going to rephrase our original question, our hypothesis. We're going to identify those variables again, okay? And then we're going to support that conclusion with evidence. And our evidence is always contained in our observations and results section. So we always have to support that conclusion with evidence. And then if we want to take it one step further, maybe we're going to perform some additional research so that we can actually identify what's maybe happening on a micro level, maybe at an atomic level, just to give our investigation a little bit more credibility. Okay, so that's basically it, the scientific process in a nutshell. Get out there and enjoy. Anyone out there, whether you're young or old, and if you want to know more about the world around you, you are a scientist. So you should definitely go in and out of this knowing that you are a scientist.